Hello, everyone. My name is Anthony Catindig Jr. I'm from DSIT 401I. So today we are going to uh, create a multiple linear regression model using RapidMiner. So first, we are going to retrieve our dataset for this task. So let's do that. So as we can see here, this is our dataset. So this dataset is about the life insurance costs of different customers. So this dataset contains these attributes. So first is the age of the primary beneficiary of the life insurance. Then the gender. So for gender, one is female and zero is male. Then BMI is the body mass index of the person who has the life insurance. So BMI is where we can base if the person is normal, overweight, underweight, or has obesity. Then for the children, children is for the number of children that are covered by the health insurance or number of the dependents. Then if the beneficiary is a smoker or a non-smoker. So one if they are smoker and zero if they are not smoker. Then region. So we have four regions. So one is for northwest, then two is for south northeast, then three is for southeast, four is for southwest. Then the charges. So the charges is the individual medical cost billed by health insurance. So let's check the statistics. So we can see that we have no missing values for this dataset. So let's jump back right into the design tab. So what we are going to do next is we are going to get the correlation matrix of our dataset to see which values have a relationship with our target variable, which is charges. So in order to do that, we are going to type correlation matrix. So let's type here, then we are going to select all, then connect the map to the result. And as we can see here, here's the result. So age have a 0.299 correlation, which is a weak positive linear correlation. Then sex has a negative 0.057 uh, neg correlation, which is uh, no correlation. Then BMI is 0.198. So it has a positive weak correlation. Then children have a 0.068. So it has no correlation. Then smoker have a 0.787 correlation, which is a positive, moderate linear correlation. Then for the region, we also don't have a correlation. Then let's remove this first. So what we are going to do next is we are going to now build our model. So first, we are going to select the attributes that we will use based on the correlation matrix earlier. So select attributes, then subset, select attributes. So what we are going to select is the um, first is age, then we are also going to select the BMI, then we are also going to select charges, and lastly is smoker. So let's do that and apply. Then click run. So here we are. So this is the result of it. Then what we are going to do after that is we are going to set the role of the charges attribute as our label. So set role, then let's choose charges and set it as label. So there we are. And next that we are going to do is um, we are going now to uh, split our data to 70-30. So 70% for training and 30% for test. Split data. Then edit enumeration, add entry 0.7, add entry again 0.3. So now, see, so we have only now 937. So we have already split the data. So after splitting the data, what we are going to do next is we are going to fit it into a linear regression. So linear regression, because we are going to create a multiple linear regression. So for this, we are going to connect the um here we are going to run it now. See? So the p-value is 0, so it's good because if it's below 0.005, then code is for asterisk, which is good, which means it has a good relationship with our target. Then next is we are going to apply the model. So we are now going to make a prediction using apply model. So for this, we are going to connect the par here to this uni in apply model. Then we are going to select this, so log into the result. So now we can see the prediction that we have made based on these following attributes. So age, BMI, and smoker. And after doing that, what's left to do is to check if we have if the performance of our model, if it makes a good prediction. So in order to do that, we will use performance. So performance regression. Then we are going to connect the um, mod to add the exa to the res, and then model to the another res. Once we run this, we should see this. So let's edit this first. Let's add, aside from root mean squared error, we need to also get the correlation. So the new correlation. So check the performance vector. So for root mean squared error, we have 6,255.357. Then the correlation, we have 0.854. So this means that we have a strong positive linear correlation in our model. So it performs well based on this. So that's all for this activity, and thank you.